Hello everyone, welcome to another video of my channel. Today we'd like to talk on a new problem named merge k sorted lists. This is a very interesting and important problem. So let's get started. At first, let's see what this problem says. It says that you are given an array of k linked lists named lists, where each linked list is sorted in ascending order. What you'll have to do is merge all the linked lists into one sorted linked list and return it. So we will be given a list which is a list of linked lists. That means this 145 is a linked list, 134 is a linked list, and 26 is a linked list. The property of each of these linked list is each of them is sorted in an ascending order. See, all are sorted in an ascending order. What we will have to do is merge all these linked lists to one linked list, and it will also have to be sorted like this. Now let's start solving this problem. We will be solving this problem using a common and important data structure named priority queue, and we will implement a mean heap using the priority queue. So our first step will be take a priority queue of type pair of int and node, which represents a mean heap. This is our list of linked list. The unit of each linked list here is a node. So this is a node, this is another node, this is another node. So in order to solve this problem, we will take a priority queue. Now the priority queue will be of type pair. Why pair? Because this node is a built-in data type. Let's see the structure of this node. This is the structure of a node. Each of this node has a property named value, which is an integer. That means this 1, 4, 5, these are the values, and each node has a pointer to point its next node. Here let's say this arrow is a pointer, so this very first node is pointing to this second node having value 4. Now if we define our priority queue, how does it look? It looks something like this. Now we will have to define this priority queue will be which type, or what type of data this priority queue will contain. We will use pair. The first value of the pair will be of type int, and the second one will be, say, the pointer to node. Why we are using this, I will discuss it very soon. Let's at first define our priority queue. We all know that in C++ the priority queue by default is a max heap. By max heap we mean that the data will be sorted in a descending order, but here we need to sort our data in an ascending order. So we will have to make our priority queue a mean heap. How can we do it? For that purpose, what we will have to do is we will have to define the container and compare function here. So at first let's define the container. Here our container will be a vector of type what? Vector of type this pair, where the first element is an int and the second element is a pointer to our node. Now the third value here will be a compare function. So we will use a built-in compare function named greater, which will be of the type this pair. So we got our priority queue. Now the question is why we are taking this pair. Because our priority queue needs to, when we push each value to a priority queue, by default this priority queue insert that value by sorting it. That means whenever we push to a priority queue, the queue will insert the element in a sorted way. Now if we did not use a pair here, the node being a user defined data type, it cannot compare the value. So we will be using a pair where the first value is an int. By this integer we mean the integer value inside the node, and the second value of the pair is the node itself. So whenever we push a pair into the priority queue, it will sort that element or sort that pair by the value of this int. Now let's go to the next step. The next step is iterate each node of each linked list of the list. That means we'll have to run a loop. Our list, this list is actually like this. Here each linked list, this is one linked list of the list, this is another one, this is another one. At first we will have to go to this first list and then we'll have to traverse through the linked list. Whenever we go to a first list, we will get its first element, but in order to get the other element, we know that we will have to traverse using the next property of this node. Once we get this 1, after that we will be able to get this 4 and 5 like this. When we get 5, the next of 5 is null, so we go to our next linked list and traverse in the similar way. So what our idea is that while running a loop and traversing each of the element, we will push each node by pair. That means at first the integer value inside the node and the node itself. So at first we will push this one. We simply pushed our this node here. Here 1 is the value inside the node and the node itself. Now we go to the next node. We are done with the next node. Now the only node left in the first linked list is this 5. Let's push it also to the priority queue. So we are done with our first linked list of the list. Now we go to the second linked list. Now the question is, where will this 1 be inserted? By default, the property, according to the property of the priority queue, this 1 will be after this very first node. So it will look like this. Now we go to the next node, that is this one. This node will be pushed next to this 1, in between this 1 and 4. We are only left with this node. This node will be inserted in between this 3 and 4. Now we are only left with the last linked list. The very first node of this linked list will be inserted in between this 1 and 3. Now the only node left is this 6. We can very well say this very node will be inserted at the very last. One thing to remember is that we do nothing. We just push this each node to the priority queue, and priority queue, by being a mean heap, it itself manages these things. So we are done with our this most important thing, that is pushing all the nodes along with its value to our priority queue. Now the rest task is pretty much straightforward. What we need to do is simply we pop from this priority queue, and when we call the pop function, the very top of this will get this, the very top of this priority queue, which will ensure us that this is the smallest element present. So our idea is pretty much clear. We pop each pair from this priority queue, and we will only take this node part, and we insert all this node to a linked list and return the head of this linked list. We are popping each pair from the priority queue and add each node to a linked list. At first we get this pair. We are only interested in the second portion of the pair, that means this node 1. So we take this node. This will look like this. Now our top of the priority queue is this pair, so we take this node and insert it next to this node like this. Now this node, and after all this nodes, so let's repeat the process and complete our linked list. So we got our linked list. Since in order to return a linked list, or in order to show a linked list, we need the reference of the head or the very first node of the linked list. So we will have to keep the reference of the head of the linked list and simply return it. This will be our head, and we will return this node, and that will be our final answer. Now let's solve this problem in Leetcode and let's submit it. Let's see what happens. So we got accepted. Here we solved the code in the similar way just we discussed. I hope by this video you got to understand the problem and its solution approach. Thanks for watching. Thank you very much. Happy coding.